Hi, students, and welcome to today's lesson. I'm Mr. Hunter. Today, we will explore the question, how do the properties of solids and liquids compare? Are you ready? Grab your pencil and your science journal, and let's get started. Observe this piece of modeling clay. Do you think the modeling clay is a solid or a liquid? Maybe you think the modeling clay is a solid, but you're not completely sure. What evidence supports your thinking about the modeling clay? Do you think the modeling clay is a solid because you can hold it in your hand? Maybe you know that solids can be hard or soft, and the modeling clay is soft. Great thinking. In a previous lesson, we observed pennies, paper clips, and erasers, which are all solids. Can you think of any liquids? I know water is a liquid, and so is orange juice. How can we learn more about solids and liquids to improve our descriptions of them? I have an idea. Let's observe different solids and liquids. Then we can compare their properties. Our observations will help us answer the question, how do the properties of solids and liquids compare? Today, we will visit 6 stations. Each station contains a different solid or liquid sample in a container. We will observe and record the properties of each sample, and then we will pour each sample into a second container and see whether any of its properties change. Are you ready? Let's begin. The vegetable oil is a liquid. What else do you notice about the properties of the oil before pouring? The oil is yellow and it looks short and round. The surface of the oil is flat. Let's see what happens when we pour the oil into the second container. Do you notice any changes after pouring? In the first container, the oil is round. In the second container, the oil changed from round to square. But the oil is still a liquid and it is still yellow. Let's observe the cotton ball next. Is the cotton ball a solid or a liquid? It's a solid. What other properties do you observe? I see that the cotton ball is white and round, and it feels soft and fluffy. Let's pour the cotton ball into the second container. Do you notice any changes after pouring? No! The cotton ball looks exactly the same as it did before. There is no change to the cotton ball. Our next sample is orange juice. What properties do you observe? I observe that orange juice is a liquid. It's orange and it looks short and round. The surface of the orange juice is flat. What do you think will happen when we pour the orange juice into the second container? Let's find out. Do you observe any changes after pouring? The orange juice is still liquid and orange, but what do you notice about the shape after pouring? The orange juice changed from round to square. What do you notice about this dye? I see that it's a solid. The dye is black and white with a square shape and smooth texture. What do you think will happen when we pour the dye into the second container? Wow, there is no change to the dye. The dye looks exactly the same in the second container as it did in the first container. Let's observe the water sample next. What do you notice? Do you notice that water is a liquid and it is clear? I noticed that too. I also noticed that the water is shaped like a square. Let's pour the water into the second container. Do you notice a change after pouring? Yes, the water changed from square to round, but the water is still clear and it is still a liquid. Here is our last sample, a bead. What are the properties of the bead before pouring? I see that the bead is solid, red, and round with a hole in the center. The bead feels rough. Let's pour the bead into the second container. Do you notice any changes after pouring? No, the bead looks the same as it did before pouring. There is no change to the bead. Think about all the samples we just observed. What did you notice about the properties that changed after we poured the samples into new containers? Let's start with the solid samples. What did you notice about the shape of each solid sample in its new container? The shapes of the cotton ball, die, and bead are the same in the new containers as they were in the old container. Now let's look at the liquid samples. What did you notice about the shape of the liquid samples after we poured each one into a new container? Maybe you noticed that each liquid sample was the same shape as its new container. Did any of the other properties of the liquid samples change? No. Other properties, such as color, stayed the same no matter which container the sample was in. So the solid samples kept their shape when we poured them from one container to another. But the liquid samples took the shape of their new container. One of your tasks for today will be to respond to questions about solids and liquids. Let's look at one more sample. What do you observe? I see a lot of red beads in a jar. The beads are solid and red. Will the properties of the beads change when I pour the beads into the new container? The beads poured like a liquid, and they spread out in the new container. But the properties of each bead are still the same. The color, shape, size, and other properties of each bead do not change when we pour the beads into a new container. Vegetable oil, water, and orange juice are examples of liquids. The shape of a liquid changes depending on the container the liquid is in. The cotton ball, bead, and dye are examples of solids. Solids have a stable shape, which means their shape mostly stays the same. But wait, what about the modeling clay we observed at the beginning of the lesson? We think the modeling clay is a solid, but we can change its shape. Why does the shape of the clay change? I noticed that when we pull or squeeze the modeling clay, its shape changes. The clay is a solid, and solids usually have a stable shape. But pushes and pulls can sometimes change that shape. We made this list of properties of objects and materials by observing solid objects. So we know that size, shape, and mass are all properties that can be used to describe solid objects. And we have also seen that liquid samples have a shape, the shape of their container. Do you think liquid samples also have mass? I think so. Liquid samples are made of a material, so they must have mass. Like solid objects, liquid samples have size, shape, and mass. We can find out the mass of a container of liquid by using a digital scale. One of your tasks for today will be to write 2 questions you still have about solids and liquids. Maybe you wonder, are there other properties of solids and liquids we haven't observed? Or can something be both a solid and a liquid? Maybe you want to know, what are other examples of solids and liquids? Great questions! In our next lesson, we will learn more about solids and liquids as we continue to explore the question, how do the properties of solids and liquids compare? Let's review your tasks for today. First, respond to the questions about properties of solids and liquids. Second, write 2 questions you still have about solids and liquids.